Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izzuddin bin Azim. Uh, Today I am going to talk about what I have learned in the Composite Structure course. Mm, okay, first of all, uh, what I have understand uh, about the E, the elastic modulus, the G, the shear modulus, and the Poisson ratio. Uh, for this course, it is composite structure. So I will use our assignment here. Okay, we can see that this is isotropic. Uh, there is mm, actually isotropic is many material is an isotropic. For example, here we can see that mm, this is all isotropic because what is mean by isotropic? Isotropic is uh, the elastic modulus in x and y direction is constant. It is the same. Here we can see that's why uh, it get only one value instead of x and y because it is the same for isotropic. Uh, Here you can see, for example, aluminum 20146. It has 73.1 GPa of modulus of elasticity and have 27 GPa of modulus of rigidity. And okay, what is mean by um, modulus of elasticity? Okay, it is mean that mm, like the strength of the material itself. The higher the stronger. Okay. Uh, I mean, how much it is mean how much force it can handle before it deform or produce deformation, plastic deformation. Okay, this is for elasticity. The rigidity is for the shear strength. Okay, it is like this one. Okay, we can see here. It is like this. Okay, okay. Mm, Next one. I will talk about the Poisson ratio. Poisson ratio is basically the ratio of uh, the the ratio of the transverse over longitudinal stress. I think. Sure, wait. Oh, okay. The Poisson ratio is the ratio of the uh, transverse what we call transverse elasticity of the in transverse direction over the elasticity in longitudinal direction. It is negative of that because it is mm, because Poisson ratio is because y is negative. uh, Negative is because the it is it is opposite uh, of, let's say, we the direction of the force going in x direction. So the Poisson ratio is we want to know what is the force in the perpendicular in that force that apply. uh, we want to know that. Okay, now I want to talk about this stress strain relation in metric form. We can see that uh, we know that the Young modulus equation is it is E elasticity equals to, okay, we know that the Young modulus formula is E elasticity, modulus of elasticity is equal to the stress over the strain. So here, this is the stress strain, this is the strain, this is the stress. This is actually coming from that formula. So we can see this is the formula, uh, but the difference is here we have in x direction, in y direction, and why there is no in z direction, because here we can see this in this stress strain relationship we have the, what do you call here, the, no, it's okay. We going to talk about this later. First of all, I want to explain about this. We have in x direction, in y direction. Why there is no in z direction? Because in real world in real world situation. Okay, let's take an example of okay, this this shape. Yeah, I will I will I will explain about the shape. We can see that the most of the force that can deform the material is in x and y direction. So basically we can neglect in z direction because it is mm, almost impossible to deform in z direction, because uh, the moment of inertia is really big, so it is almost impossible to deform. Okay, from this stress strain metric relation in metric form, this one is for, instead of z that I'm talking just now, we replace with the other important aspect, which is the shear, shear strain, itself, and this is shear stress. So this is the formula. That's why this is zero, because it is not in x and y direction of the elastic and stress relation. It is, so we have instead of z we have stress strain, shear strain and shear stress relationship. Okay, next one I will talk about the anisotropic. It is same as isotropic, but what is different is now we have two direction, x and y, because okay, this is glass is actually isotropic, so that's why it is have the same. We can look at here, glass, it is isotropic. We're gonna talk about these three materials. Actually there's more, but it is I'm just taking out of the book. It gives these three materials of an isotropic. Okay, we can see that in Kevlar, we can see that they have two different elastic modulus of elasticity. Okay, we can see that Kevlar have 130,000 uh, of MPA, yeah, MPA, in x direction or longitudinal modulus, yeah, and it just have 505 554,000 5400 MPa of elasticity modulus in y direction. So so that is the difference between isotropic and isotropic. Yeah, that is the most obvious one. Uh, Other than that, I would say it is actually the same. Just have shear modulus of x and y and Poisson ratio, just like isotropic. Okay. Next, about the stress-strain relationship, also same as before, but what is the difference is just in the formula itself, because now we have different models of elasticity in x and y direction. So, I'm sorry. In an isotropic, we have a different Poisson ratio actually, uh, because we need yeah, because we have a difference in Poisson ratio also, because there is because we have modulus different in modulus elasticity in x in y direction. So we also have Poisson ratio xy and Poisson ratio yx. This is the formula we can quote for the Poisson ratio in xy direction. Okay, next, uh, I'm going to talk about the unidirectional ply. Okay, this is what is more uh, in real life situation, because composite structure is actually is the combination of the matrix and fiber. We usually use an isotropic as use an isotropic as a fiber, yeah, as a fiber, and we use other material matrix, and then we combine, excuse me, we combine matrix and fiber to form a composite structure, which is what follow what is our desire to make the material. Okay, for example, if you want to make something stronger and lighter, we can do that. For example, we want to make okay, for example, we want to make uh, Kevlar, armor Kevlar. You know, in military, they have a Kevlar body to penetrate bullets so that they don't die in war. So yeah, they do that in composite structure. Okay, how they do that? Mm, they do that in uh, basically in this unidirectional ply. We Okay, we can see here we have material of material of fiber, and then we have a volume fraction between those two, based based on what we want, based on what desire we want to make our product. Okay, basically it is just, we can see here, it is like ply consists of fibers and metric stuff. Okay. Mm. what is the factor affected? Okay, factor affected, I would say this one. uh, the angle, of the fiber and matrix, it has effect of the modulus of elasticity. Okay, let's say here, if we want to, we can see here, uh, mm, okay, if the angle, okay, I will just this is just constant. I will put 75% of volume fraction of fiber and 25% volume fraction of matrix. Okay, now this is the factor that affect the modulus of elasticity. We can see here, if the angle between uh, the fiber and metric is, let's say we take 50. Okay, you see the modulus of elasticity is changed. How about 95? Because why? Because in 90 degree we will just get the modulus of elasticity of the composite in transfer direction directly. So we can say this is the weakest, so we don't want the angle to be 90 degree. We want the perfect is 0, so we get uh, we get most of the elasticity of the composite material. So this is the one of the factor in unidirectional ply. Okay. Okay, I think that is all from me for what I've learned in this course so far. For the next I will talk about my opinion of the learning process. Mm, I think this is the best approach for me, because because we can I can hear you, I can watch your videos whenever I have times. So and then just we I just the sign in and sign out method, I think that is okay with me. uh, okay, second opinion on how effective assignment approach, I think it is also good approach of doing the assignment, because now I know how Excel's work. Before, I don't know Excel can do this type of thing. Honestly, now I know. And of course, if I don't know, I can refer to my friends, and I refer to internet, now so that now I know more of doing the Excel on the assignment. So I think this is a good approach of the assignment. The third one, opinion on best assessment approach. I think this one, the assignment is good. Uh, be, yeah, because it is I am comfortable with it. Maybe for the project, I don't know about the project, because I don't really clear about the project itself, how you want to make the project group or individual. I don't know. So the test mm, I, I I also don't think test is the best approach. Yeah, exam, because during the CRTL we can just Google, we can just Google anything. So maybe that is not good for us. I don't know. Okay, before I end my assignment, I want to refer back how effective this assignment approach. I think that is very effective because as you said, we don't need to to compute all the formula because the formula is just the same, right? So the Excel assignment is very good. Is very effective because we just change whatever material we want and 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 it will just compute what we want in these properties, in these parameters, property parameters. So I think that is good. This is very effective. Okay, that's all from me. uh, Thank you, sir.